Perfect. All right. So this is kind of the first actual instructional session of this class. 2 days ago, we had Scott Olson from Consensus over to give us kind of a little bit of a history and a background of the situation with Ethereum and dApps and all that stuff, which I found very interesting and informative and hopefully inspiring for all y'all taking this teacher training track. So let me just share my screen here. Right. All right, are you able to see? Okay. Wow, look at that. Perfect. All right. So, this was kind of the reading for this session, and hopefully you were all very familiar with all this information already. This is supposed to be very foundational information here, just intro to blockchain and smart contracts. So, there is a short presentation that I have right here. We're just going to run through it really quick and just make sure that we all have this same foundation, right? Okay. So, blockchain technology, that's kind of like a really hot buzzword. I know a couple years ago we were trying to put everything on blockchain from from tea to lettuce to supply chain to the Mona Lisa. Everything was getting put on the blockchain. But what actually is blockchain, right? So remember linked lists from your data structures class. I like to think of blockchain as kind of like a souped up linked list structure, right? So we have a structure here. This is like a Java-ish class, right? So we have this object and it contains a pointer, essentially. This is a singly linked list, meaning we only link in one direction, to another node in our linked list, right? And when it comes to blockchain, it takes the form of blocks, right? So we have a block and it has an ID, or at least this block has a block ID, and it will point to a previous block's ID, right? So that means that blocks are kind of arranged like a linked list. So in a linked list, you have your first node that points to your second node, to your third node, and finally to your last node. Your third node points to your fourth node here. And then blocks, they kind of do it, the newest block points to the previous block, the block that it came from, and so on and so forth, until you get to the oldest block, which is called the genesis block, right? Each block, when it comes to blockchain-based cryptocurrencies, they have this property called block time. And this is a factor that plays into how blockchain-based cryptocurrencies, their blockchains are kind of like living data structures in that they're constantly being updated. So the block time is going to be the span of time that each block represents, right? So, in the case of whatever blockchain this is, it has a 1 hour block time, right? So this block started at 6 p.m. and ended at 7 p.m., and all of the data inside of that block represents whatever activity occurred from 6 to 7 p.m., right? So yeah, block time is just the duration between one and the next block. Cryptocurrencies store transactions in blocks. So if we go back here, right, the data in our blocks is going to be transactions. It's going to be activity that occurred in the network in that period of time. So for example, the data portion of a block might contain something that looks a little bit like this, right? A transaction from Alice to Bob with the amount of $10, from Charlie to Dana with the amount of $15, right? So that would all be, if these were all in the same blocks, that means, in the case of this cryptocurrency here, they all occurred within like an hour of each other, right? And this brings us to what's the idea of a shared or distributed ledger, right? Because if we're sending money from one person to another person, perfect. So if I'm sending money from one person to another person, and I'm the only one who has a record of that, no one else knows that I've sent money from someone to someone else, and so, digital data is infinitely replicable. So I can't just say, hey, look, I have $10 because I have 10 crypto coins because anyone else can just say they have 10 crypto coins, and then there's, who's to say someone's right, someone's wrong. So when it comes to cryptocurrency-based or blockchain-based cryptocurrencies, we use this concept of a shared or distributed ledger, wherein everyone has a copy of the same blockchain. So whenever you want to add updates to the blockchain, you have to update everyone's blockchain. But of course, that means that we need to agree on what changes get added to the blockchain and what changes don't get added to the blockchain. Because, for example, what if I said that Alice sent me $10,000? I can't just say that, because then, Alice doesn't really own her money if I'm allowed to say that, and just make everyone believe that Alice sent me $10,000. So we have to come up with some sort of consensus mechanism to decide which changes get added to the blockchain and which changes don't. And so this brings us to the concept of mining in proof-of-work cryptocurrencies, which is like making free money, except it's not actually free. We'll get to that. My clip art is lacking. Sorry about that. So how do we make sure that the nodes agree? And, what could a node do if there were no accountability? And these are kind of like brainstorm questions. I'm guessing that most people here already know the answers to this, because you're here. So you're probably all familiar with proof of work, and so can I just hear what some any just like shout out ideas? What could a node do if there were no accountability? Just unmute and shout it out. What could a node do if there were no accountability? If there wasn't a consensus mechanism and everyone just agreed to everything that got sent to the network? Can you give us some examples, maybe? Just shout them out.
Probably change account balances.
Yep, that's a big one. Sorry, what was that, Bassam?
It could probably fake a transaction.
Mm-hmm. Yep, absolutely. Definitely. So, yeah, definitely, like, the biggest thing is just arbitrarily changing the state of the blockchain, and if there's no way to make sure that people are only operating within the rules, there's no accountability, then, things are going to go awry really fast. So, proof of work blockchains typically use mining as their consensus mechanism. Is everyone familiar generally with the idea of mining? It was kind of fleshed out a little bit more in the reading that we had here, a little bit more. Proof of work was described here. Is everyone pretty clear on how proof of work works? Or rather, is anyone not clear on proof of work just generally? Should we go over that in more detail?
So I understand the concept of like using like the computing power to solve I guess I don't understand proof of work too much of why, especially at the sort of end when the transactions are met, what happens if one of the computers does not meet consensus or something.
Right. Perfect. Okay. So we can definitely go over this, but this is part where I want to kind of inject more of this is a teacher training track portion of this program. So part of the lesson plan, I'm just going to pull this up here, is a topical micro presentation. And the idea behind this is that you're going to choose a small topic that maybe interests you, maybe you already have a really good understanding of and you want to dive deeper into, or find a creative way to describe it just in 2 minutes. So, did anyone prepare a topical micro presentation about how proof of work works? Or is anyone willing to impromptu describe how proof of work works in under 2 minutes?
Yeah, I'll jump on that because it's something that I've been learning more about, is dealing with mining Bitcoin or a proof of work token utilizing stranded gas in the oil and gas sector in the Permian Basin, right? So basically what happens is when it comes to proof of work, that's the token that you have the ability to mine. And then the proof of stake, with the new Ethereum protocol coming out, there will be a small window where individuals still will have an ability to mine, and they will then stamp the block at said point in time. So basically, how I see this whole thing when it comes into mining is the fact that proof of work, yeah, we mine it. Proof of stake, we're really not going to mine anymore. But I know it has to do something along with like the 51% attack keeps sitting in my head, but correct me if I'm wrong in that regard too as well. And that's a part of these tokens and these blocks being put together, and then they get validated at a certain time, and that transaction they get paid for what they did for validating that, hey, we mined it the fastest. And that's like a low level way of kind of explaining.
Right, yeah, I think you hit on a lot of really good stuff there. So just to kind of like tie it up in a bow, proof of work, I think your question specifically was like, what is the penalty if someone doesn't follow the rules?
Yeah.
Yeah. So with proof of work, it depends, I suppose, on what you mean by not follow the rules. Do you mean like they successfully mine a transaction, but they failed to properly validate all of the transactions within the block? Yeah. Or mine a block, but failed to properly validate all of the transactions within that block. That's exactly the question. Yeah. Yeah. So, typically, your nodes are going to, so they kind of have to decide which blocks to trust, right? So if a node is just throwing out randomly, like just completely invalid blocks and claiming that they've solved it, right? Part of what makes mining so interesting is that it is very difficult to solve. It's difficult to mine a block, but it's very easy to check if a block has been mined correctly, right? So anyone can just say, I have decided that I don't think that this block is valid, and accept, the second place winner, I guess, who mined that that block, right? And then you're going to have a fork in the network, right? You're going to have, some nodes agree that this is the valid block, and the valid block to continue the blockchain building, and other nodes are going to agree that this is the correct block to keep building off of, right? So you're going to end up with a fork in the network, which is kind of a problem, because then only 50% or, a fraction of people are going to agree which transactions are actually valid. So eventually, what the network decides to do is follow the chain that is the longest, because it represents the most work that has been done so far. And so that typically means that the most trust has been put into that specific chain, because the most time, money, and effort has been put into maintaining that chain. So nodes can revalidate the mining, because it's very easy to validate a mined block, right? All you have to do is compute the hash once, right? You don't have to compute it however many times to find the nonce. You just have to compute the hash once. And so then if the network decides to fork, then eventually it will just be the longest chain that gives. That's correct. That's decided to be correct.
Okay.
That kind of help? Perfect.
Yeah, helps. Thank you.
All right. Awesome. Okay.
Yeah, because also, too, they'll get in trouble if they get kicked out, and they're not going to want to run that risk and lose the fact of making money, because that's why they're there,
Mm-hmm.
Yeah.
Perfect. So that's proof of work networks. Proof of stake networks. Sorry, I'm talking too quickly. My tongue can't keep up. Proof of stake networks. I suppose it kind of helps to make a comparison like this. Think of proof of work networks like the miners are submitting their electricity bill as collateral that they will be honest in their actions on the network, right? So it's like, if I'm dishonest, I'm wasting all of this electricity and hardware costs because you bought hardware and you're using it, whatever. But just think of it like they're submitting their electricity bill as collateral to the network that they will be honest to the network, right? Proof of stake networks instead say, okay, we're going to actually use the crypto that you already own as collateral, right? So instead of, your electricity bill, which is kind of like an out of network thing, I mean, it's just a way of thinking about it. I find that it helps me to understand it a little bit more intuitively. Proof of work versus proof of stake. So proof of stake is just, if Bitcoin were a proof of stake network, instead of, pumping hundreds of dollars or probably hundreds of thousands of dollars into your mining warehouse in electricity, instead you just say, all right, I have $100,000 worth of Bitcoin, which if I'm dishonest, the network is allowed to reappropriate, So that's just two ways of ensuring that people are honest on the network. Right? So that's proof of stake, consensus algorithms. It's a category of algorithm. Consensus algorithms that use staking of collateral to create trust, and proof of work that use computational complexity or work to create trust. And in exchange for all the work that they're doing, miners get a couple of different things. They get a say in the network, meaning they get to decide which transactions make the cut, which ones don't, technically. They get transaction fees from transactions in the block, which means they're incentivized to not exclude transactions from a block, because each transaction that they add to the block, they get to collect transaction fees from. And then they also get free crypto from a Coinbase transaction, or at least they do in the case of Bitcoin, where right now the Coinbase transaction, I think, is Bitcoin still at 6.25, or did it halve again? I'm not entirely sure.
I'm not certain on that either. Yeah. I'm not
Sorry,
sure.
what do you mean by 6.25?
Like the halvening.
Yeah. Is it?
I think it is.
So essentially, a Coinbase transaction is like every time a block is mined, a miner is entitled to create a transaction in that block that has no inputs and an output of the value of, right now I think it's 6.25 Bitcoin, which is like a lot, like $120,000 or something like that. So, and since Bitcoin blocks occur every 10 minutes, that's how much money being added to that network every 10 minutes, and the miner just gets to direct that transaction wherever they want. So that's how new crypto gets added to at least the Bitcoin network.
So that's like the winner of the block gets to do that, right? The one that figures out the value.
That's why mining is such a big industry, because every 10 minutes there's hundreds of thousands of dollars up for grabs.
Right. I actually did not know that.
Yeah, I think it's still 6.25. I should look this up.
It's 6.25.
It is? Okay. Thank you. Perfect. All right, so now let's talk about smart contracts. And Ethereum operates in a similar way. Because right now Ethereum is a proof of work network. Right. So smart contracts allow our transactions to do more than just transfer money. In the case of Bitcoin, surprise, surprise, actually does have a smart contract language. I'm not 100% sure if it's Turing complete, but it can do more than simply transfer money from one account to another. It's very simple. It's like a stack-based language. Honestly, I should have put the links there because I looked it up. I read into it. It was kind of interesting, but mostly just sad how weak it is compared to Ethereum's. But anyway, so we have these smart contracts, and depending on the network, it can be executed at different points in time or in different types of transactions. But essentially, and for the purposes of this course, we're going to be focusing on Ethereum. So Bitcoin smart contracts are not going to be very important because they're not very useful anyways. But smart contract is going to be code that we deploy to the blockchain, and then using special transactions called message calls. I'm literally reading the slide. We can interact with them. And the really interesting thing about Ethereum smart contracts is that they can act just like a regular account, like another person almost on the blockchain. You can just send them crypto. You can just send a computer program crypto, and it will act. It can act just like a person, and it can send someone else crypto or something like that. So, pretty interesting. And we're going to be focusing on the development of these smart contracts in Solidity in this course. So, this kind of modifies what our concept of transactions might be in our block. So instead of just being a simple from, to, and amount, instead now maybe if so Alice sends Bob $10 and a result is success. Yay, cool. But what if Charlie sends our smart contract called SC_add $1 in exchange for computing this rigorous mathematical proof, and gets back the result 3? I'd say that's worth $1, right? But yeah, so this kind of modifies what our idea of a transaction on the blockchain might look like, right? Because now instead of just sending from person to person, we can send from person to contract, or we could also send from contract to person or contract to contract with send Ethereum values around and send extra data appended to it in the form of different parameters and get return values and stuff like that. So we have a lot of use cases for smart contracts. Here is just a very small selection: auctions, elections, trading. Obviously, on top of smart contracts, you've probably all heard of like ERC20 tokens, where someone implements a cryptocurrency on top of Ethereum, right? So it's like a cryptocurrency inception type deal. And yeah, that's done using smart contracts. So, but smart contracts come with a lot of very interesting limitations, because they are stored on a public blockchain, meaning that anyone can view the source code and can also view the current state of the contract. There's no such thing as like private memory or like private access modifier variables. Although there is with contracts interacting with each other, there's access modifiers, but anyone can just go on the blockchain and calculate what your super secret private variable value is. It's trivial. But since these smart contracts live on the blockchain, on the Ethereum network, and on any one computer or any one node, that means that when they're executed, because they have to be executed in the context of the network, you can't actually get information from any specific node or from the internet. You can't make a network request and say, hey, what's the weather like today? Because it has to be deterministic, meaning it has to be the same. The result of your smart contract's execution has to be the same no matter what node is executing it. So, what if a node, for some reason can't access, the website you're trying to access? Well, then it wouldn't be deterministic. So that also means you can't do anything like no random number generation. You can't access any networking. No, what's the weather out? No, what time is? Well, you can kind of do what time is it by looking at the block timestamp, but it's not a true what is the microsecond time right now. Can't ask what an IP address is. Can't ask what the host name of the node is, because you're executing in the context of the nebulous network. Determinism is a big thing in smart contract development. Everything is deterministic. So when we write smart contracts on Ethereum, we use one of two programming languages, Solidity or Vyper. We are going to be using Solidity in this course. Solidity is the more mature one of the two. Vyper, it's not that it's a bad language, it's just Solidity is a heck of a lot more popular, and I already knew Solidity. So Vyper is a little bit more like Python. I think it's like inspired by Python, which is why the name is Vyper. And some people might prefer it, but we're going to use Solidity for this course. And that is it for this presentation. So we'll just kill that here really quick. All right. So now we're going to, so that covers the material presentation. Did anyone have any questions about that before we move into the next section of the session today? Yes, no, maybe so. Questions, comments, concerns, criticisms, discombobulations.
Yeah. Why is Bitcoin a balance type thing in no, it's backwards. Bitcoin is like a transaction in Ethereum's balance. I don't understand Ledger. I don't understand why it's that way. I would think it'd kind of be flipped because Ethereum's faster, and when I think of transactions, I think of speed. So I never really got why it's that way.
I'm not sure I understand the question. So they're both like distributed ledger technologies. They both operate like transactions are the individual operations that the network performs. They both use blocks that contain transactions over a period of time. They're very similar in that regard. It's just like Ethereum transactions can do a lot more. And the idea of like everyone carrying a balance is, so it's actually kind of interesting to think about, because a cryptocurrency, when they're keeping track of people's balances, like, oh, you have 2 Bitcoin, oh, you have 5 Bitcoin, it's less of a spreadsheet where, or the spreadsheet where it's address balance is more of a side effect of the network than like a primary component, because the network operates in terms of transactions. So it operates in terms of like deltas, right? So instead of keeping track of a fixed balance, you just say, all right, this address started at 0. They were sent 5 Bitcoin. They sent away 2 Bitcoin. They were sent 10 more Bitcoin. They sent away, 4 Bitcoin. Now how much Bitcoin do they have? Right? So the network is keeping track of changes, and then you can calculate all of those changes to arrive at a balance. And nodes will, keep track of balances as kind of like a time-saving measure, because you don't want to have to go through the entire history of the blockchain to figure out what someone's balance is, to see if they're able to, and it's to see how much Bitcoin they have. So they do still keep track of that, but it's more of a side effect of the really foundational components of the network. Does that make sense? Does that kind of answer your question?
Yeah, it does. I see a better picture of that. Thank you.
All right, perfect. Okay, so any other questions? Joseph, you had unmuted.
Yeah, I'm sorry. So I kind of missed, you started talking about deterministic, how it's related to the blockchain, and I was wanting a better understanding of that. I had to plug in my laptop, so I missed part of that.
Yeah, perfect. Let's see. Did I have a... Perfect. Okay, so a smart contract needs to be deterministic in its execution. And what this means is that no matter who is executing your smart contract, given your smart contract's state, and the input given to the smart contract function call at the time of, like by the transaction that's calling it, anyone, no matter who is trying to execute it, must So given these three things, the state of your smart contract, the code of your smart contract, and the input from the transaction, everyone who executes your smart contract will result in the same change in state of that smart contract, right? So after that transaction, everyone who executed your smart contract code will have the same state, same ending state as everyone else who executed your smart contract code. So you can't say something like, pick a random number, because then, person A who executed your smart contract might end up with a different answer from person B, right? So it has to be completely deterministic logic. No matter what node is executing the smart contract, the change in state of your smart contract is going to be the same. Does that make sense? If it doesn't make sense, I can go into some more concrete examples.
The concept makes sense.
All right, perfect. Ziad? I'm sorry, I'm not sure how you pronounce it.
Yeah, you got it right. It's Ziad.
Ziad?
Yeah.
Ziad?
Yep,
Perfect.
perfect.
You hit unmuted.
Yeah,
Did you have a
most
question?
people don't get that right on the first try. But yeah, I was just kind of thinking about Price's question, I guess, about like consensus and everything.
Mm-hmm.
So, I guess, does every single node kind of have an updated, like, current block, like that same block time, like the current block? Does every node share that? And then that's how they kind of decide whether this block or this node was like trying to basically break the network or not.
Yeah, so every node that is connected to the very bleeding edge of the network is going to receive a copy of the latest block. Yes, is that your question?
Yeah, and I guess like with like the current transactions that say are like happening just this second, do they all receive those as well?
Yeah,
Okay.
or ideally they should.
Yeah,
see.
okay. I just see that being sort of slow, I guess. Like, I kind of wonder how, like, how they kind of share all that information.
We can watch the Ethereum network live from etherscan.io, and obviously this is going to be slightly slow, but we're receiving almost real-time updates here. So we got this transaction, they're coming in like 9 seconds after they were mined.
Right.
That's
pretty cool.
Right here, this is 19 seconds old here. So, and on average, the Ethereum block time, I think, is about 14 seconds. But on a block-to-block basis, we could see anything from probably, 5 seconds to a minute or two. But on average, it's about 14 seconds.
So how long does it usually take for a node to calculate, like, the nonce?
For any individual node?
Yeah.
Usually any individual node is probably not going to calculate the nonce, which is why we have mining pools.
Got you, yeah.
Yeah, everyone's going to try together, and, maybe one out of the 5,000 nodes in the pool are going to calculate.
And then they just, like, split that,
Right.
the capital, I guess, that comes out of it.
Mm-hmm. Yep.
Got you.
Yeah.
So I think that answered my question.
Perfect. Yeah. So this website, etherscan.io, is invaluable for understanding how the Ethereum blockchain works. So let's look at this, which was mined 16 seconds ago. And we can go through here and see. So this is the block reward. This is what the miner received. This is Coinbase plus transaction fees right now. So if we go into, where's the transaction?
So is this affiliated with like the Coinbase like exchange?
No.
Or
Coinbase copped that in from Bitcoin.
Okay, gotcha.
Yeah, the Coinbase, it is the basis from which all it's like the land, it's the base. It's the genesis of all Bitcoin. All Bitcoin started from either the Genesis block or some Coinbase transaction. Where the heck do I get?
And so, what if like a single block takes like, who knows, like an hour for like the nonce to get figured out? Does that just like not affect anything, and like all these other blocks are also happening in that time, or how does that work?
So, if a particular nonce took an hour to figure out, that would definitely be an anomaly.
Okay, yeah.
But since the entire network is trying to, it doesn't really, it's not like you say, all right, I've decided that this block is block 12,694,000 or something like that.
Yeah,
It's just, all right, whatever the last block height was, that's, I'm just going to...
everybody's allocated to...
Everyone's trying to find the next one, and it's not like we've designated...
Splitting it up.
Yeah, each miner kind of just picks and chooses what transactions they put in their block that they're trying to mine really quickly. And if they mine it first, that block is the 12,694,000 block. 94,008th block. I don't know how you would make that an ordinal number. 12,694,008th block. Yeah, that's what you'd say.
Yeah, I think you got it right.
Sorry, English is my first language and I still struggle.
No, it's super helpful though. Yeah, you're covering a lot of questions I've been confused about.
Awesome. Yeah, this is intended to be like super foundational. Like we want to make sure that all of this stuff is understood really solidly because we're going to be moving away from this very quickly.
Yeah. Thank you.
Yeah. Any other questions about this material before we move on to our topical micro presentations? Yes, no. All right. So, did anyone have a chance to prepare a topical micro presentation about this content here? If not, it's perfectly fine. Let's just, before we hop into that, I'll review the lesson plan one more time, just so for next time we can be sure of what the plan is. So, and if you didn't do it for this session, totally fine, no sweat. We're getting to know each other, getting to know the course, perfectly fine. This is foundational stuff. A lot of you guys probably already knew a lot of this, so a lot of it was probably a review anyways. The goal of the topical micro presentations is kind of twofold. One, give you a chance to look deeper into something that you found interesting, and two, help give you a chance to prepare material that you can then use in your own workshops after this course is done, right? Because this is the teacher training track. We're trying to prepare you to hold your own workshops, hold a course, a class, something like that. And so hopefully these topical micro presentations can kind of contribute, you'll have some more content as the basis for your workshop, right? So the idea here is, so for example, for next week, next Monday, the order of operations is going to be, so before the session, just read through this. It's not too long, but there are a lot of links, so there's definitely room here for you to do a deep dive, right? If you're like, oh my goodness, I really want to read through the entire Open Zeppelin library of contracts or something. Great. There's your deep dive or something like that. And then just prepare like a 2-minute statement or something like that. Maybe a presentation. It doesn't have to be a PowerPoint. It could be a blog post. You could just demonstrate something. You could just get up and talk about what you did. But if you do prepare material, that's probably more helpful if you're doing a workshop later, right? So, kind of the order of operations would be read through this, find something interesting. Maybe you go through Etherscan and find another interesting contract, something like the double or nothing contract or something. Just maybe a small interesting one or a big, long, complicated one. Do a deep dive into that. Or maybe something about, fungibility or non-fungibility in the real world or something like that. And these tags here, these topics at the top, are intended so that, like, for example, for this first one, if you were like, I'm not sure what I should look into, you can just look at these tags here. Okay, I'll look into proof of work. Or I'll look into what is staking. Or something like that. Or for one of these later ones, you can be like, okay, I'm going to do a deep dive. What is an ABI? And then do a 2-minute presentation on that. So that's just kind of the idea of what the topical micro presentation is all about. Did anyone have a chance to prepare something like that for today?
I did.
All right, perfect. Take it away.
All right, cool. Should I share my screen to show it?
Oh yeah. We'll just, there you go.
So, figure out what this is going to do. All right, let me know if you can see it.
Yep, I can see it.
All right, so I did mine on proof of work, and so like, what is proof of work? Basically, like we said, it's a consensus mechanism. Basically, you're forming agreements. It's meant to validate transactions, and it's utilized by like work by hardware that is driven by computational power, which is what the hardware generates to validate these transactions. So essentially, it's a race to solve this complex computational problem that comes through, and it's a race with like all the other miners on that network who also have set up hardware. The winner gets three things, basically like a say in what gets added to that blockchain. So they can add a block to that chain. They also receive a block reward. And the example I gave for my next slide is Bitcoin's blockchain because it is a proof of work blockchain. And you also get a cut of the transaction fees that go on during that transaction. So this is this example that I gave to help explain like what this race really looks like. And so this is a mini game from this game I used to play and still do, call it Mario Party. It's on the Switch. And this mini game is essentially, it's a race to solve this block. And you see on the left and the right, basically there's, let's say these are two miners on a proof of work blockchain. And they have this problem to bring this block together into one to solve this like computational problem. So the first to solve this problem gets the block reward and the say in the blockchain. So if we move from the left to right, transaction, and then we move, so there's a competition now between Yoshi's team and Hammer Bros team, and they need to solve this problem using their hardware. Once they solve it, so let's say Yoshi wins, he gets the block reward and he gets a say in which transaction gets validated on that blockchain. So that's basically how I wanted to explain it to you guys on what visually is going on. Maybe not on the code, but if you can think about it in your head, this is what you'll probably see. It's a race to validate the transaction and get the reward.
Yeah, that's perfect. That's exactly right. And this is like a great example of, yeah, really solid explanation. Love it. Thank you so much.
Appreciate it.
All right, and then it looked like Price, you had one on ERC20.
Yes, I do.
All right, perfect. Take it away.
I'll try and share my screen real quick. Sorry, this is a new computer. Can you guys see the tab? Oh, awesome. Let me go to that tab real quick.
Yes.
About that, I'm having trouble finding it now. Oh man. Well, I guess I'll start. So, ERC20 tokens. So sort of some background. They are sort of based on, so the Ethereum blockchain. Ethereum was launched in 2015. It's become one of the driving forces and one of the most popular cryptocurrencies. In the Ethereum system, tokens represent the diverse range of things: digital assets, vouchers, IOU, real world tangible objects. So they're a really important part of the Ethereum ecosystem. And so finding a way to create like a uniform way of them being recognized and being used in certain tools is really important. You know what? I'm having trouble with my with my presentation, so I think I'm just gonna do the rest by trying to just explain it.
Yeah, that's fine. That's fine. Go ahead.
And so, sorry, I'm just pulling up the slide deck again. So ERC was basically, and now it's loading, it's taking a bit too long. So one of the most significant tokens is the ERC20 token. It's a technical standard. It is used for all smart contracts on the Ethereum blockchain for token implementation, and it provides a list of rules that all Ethereum-based tokens must follow. There's over 200,000 ERC tokens out there, and the common then there's about 6 different common functions for the benefit of other tokens within the Ethereum system. These they have these like set out like a basic functionality, including methods on how tokens are transferred and how users can access data regarding a particular token. And I'm going to try and share my screen again because I think I have some of it figured out. So I have my screen figured out again. And I'm just going to share my entire screen this time. And I'm just going to sort of go through and just show some of the methods. So name, symbol, decimals, total supply, balance of, transfer from. So these are sort of the methods that like you can pull from when you're creating an ERC token, and you have like you're writing Solidity code. And then here are some of the events that you can also use. I think these pair well with when you're coding in like using like Web3 JS or something like that. But yeah, that's sort of my that's my little presentation. Thank you.
Awesome. Great job. Love it. Yeah, we're going to be going over ERC20. Is that the next one? I think, yeah, that's the next one. We're going to be going into ERC20 a little more in depth. So great job. You're ahead of the game. Perfect. And it's a great example of smart contracts too. Like going ERC20 standard is really a good place to start with understanding just what is the power of smart contracts, and even with that deterministic like limit, you know, we're only allowed to write deterministic code, how powerful they can still be. So yeah, that's a great place to start in learning about and teaching about smart contracts, ERC20. Did anyone else have a topical micro presentation that they wanted to share? If not, that's fine, because we have like a minute left.
Yeah, I'll drop mine in the chat.
Yeah, if you want to share it, feel free to share. It's just no one is obliged to stay on the call afterwards. Yeah, Ziad.
Yeah, Ziad.
Ziad. Oh man, I had it the first time. Ziad.
Yep.
Ziad,
I had no clue we were supposed to create them. Honestly, I kind of glossed over that content, but now that I know,
no problem. This was supposed to be like kind of the easy week, anyways. So don't sweat it. It's totally cool. And also, if you can't do it 1 week or something, or for one session, don't worry about it. We're not gonna like kick you out or anything, and nothing's being graded. So it's all for your own edification, and in hopes that you'll have materials then to present at your own workshops later. So
I think I may have slightly misunderstood it. I created a little micro presentation on what Scott was speaking on.
That's
Monday.
Perfectly fine too. Yeah.
Good,
and I good practice presenting.
Yeah, I kind of did it on my on a little bit of my own experience, and just trying to build off of kind of one of the topics he brought up.
Yeah, let's do it. Do you want to present?
Sure.
All right, perfect. Let's go.
Awesome. All right. All right. Can you guys hear me? Okay, awesome. I'm trying to figure out how to do it full screen. I can't, but for sake of time, I'm not going to worry about it too much. We'll go to the first slide though. I want to talk about the importance of user experience and its role in DApps. Obviously, if any of us have interacted with any type of non-decentralized apps, we know how important it is to have concise, clear messages. We need to capitalize on current trends, right? So we need to pay attention to what exactly is needed, what exactly the general public can benefit from, and not really ignore those types of trends. What is this number, right? So I pulled this from, I think it was worldometers.info. It just showed the current population of the world. So why does that even matter? Why is that even important? Well, because if you crunch those numbers, you see that there's roughly 8 billion people on the earth. And roughly 48% of that total population has a smartphone. That also means that 3.8 billion roughly, that's the number for that percentage. And comparing that to just crypto users, we have about 100 million. So that means there's a large room for growth. How do we do that? We do that through proliferation. We obviously want to see mainstream adoption because that'll help everyone in the blockchain crypto sphere. So we want to see more people, more moms and dads, like Scott even mentioned, utilizing the blockchain, being able to interact with it. So how do we do that? Well, these are a few closing remarks. To do proliferation, we basically need Mama Sue or Granddad Joe to be able to interact with it in a way that has simple UI UX that allows them when we are creating these DApps to be able to kind of interact with the blockchain without having to know a ton about it. A lot of blockchain concepts are high level, and not a lot of people can totally visualize what is in the code behind it. We don't need them to. We need them just to be able to understand that blockchain and decentralized apps can actually benefit them because they can interact with them in a simplistic way. And I'm done.
Awesome, great perspective. And honestly, like this is actually perfect. This script gives you like a great jumping off point for your own workshops. Like you can use this type of presentation, say these are goals, these are problems that we have, these are things that dApps need, and then you can use that as kind of like a springboard into, all right, what are we focusing on in this workshop? So I think that's still like an absolutely wonderful place to, it is a great presentation, good perspectives, awesome. And then Ryan, if you want to present yours really quick, again, no one has an obligation to stay past time. So we're 3 minutes past time, but if people want to stay and see Ryan's presentation, Ryan, if you're still willing, that would be great.
Okay, yeah. Just set it up real quick.
Yeah, and we're still kind of figuring out like the timing of this whole course because this is the pilot cohort. So we'll try and make sure that things get finished up a lot more promptly on Monday. So.
Okay, it's making me have to edit my Google settings. Okay, 1 second. Anybody else get like you have to open up Google Drive for it to present? Does anybody else know what I'm talking about?
Yeah, I've seen that before.
Can I present next time, or I sent the slides in there? But
yeah, that's fine. Yeah, you can present next time. All right.
Okay.
If there's no one else, did everyone get the attendance link? Did anyone not get the attendance link? All right, perfect. Then I think we can call it there. Again, the next section is going to be section 2. We're not necessarily going to always cover one section per session. The timing, again, of this course is still kind of being figured out. So, all right, I think that is it. I will talk to you all on Monday. Thanks so much.
All right, thank you. Have a good one.
Yeah, thanks everyone. See you soon. Bye-bye.